Hello and welcome to AS Level Mathematics. This is Omar Katan and I'll be your instructor throughout this training series. This reading is based on quadratics and will cover the most tested concepts in the GCSE, IGCSE, CAIE, ORC, Edexcel, International Baccalaureate and more. Main topics in this reading are as follows. So what is a quadratic equation? Solving quadratic equation by factorization. Solving quadratic equation by completing the square method. Solving quadratic equation by using quadratic formula. How to find the roots of a quadratic equation. Finding the intersection of line and the curve. And finally, graphical quadratic inequalities. Each topic in this chapter is followed by relevant past paper questions, where I will walk you through multiple past paper questions step by step, so you feel more confident in handling these questions on the final exam. So, let's get started. A quadratic equation is a second degree polynomial represented by ax square plus bx plus c is equals to 0. Let's take some real life equations that we often come across in the exam. 2x square plus 3x plus 5 is equals to 0. Here a is equals to 2, b is equals to 3 and c is equals to 5. So these are the quadratic equations. Now we would like to have a look how to solve quadratic equations. There are normally three methods which we use to solve quadratic equations. First, we will see how to solve quadratic equation through factorization or the middle term breaking. Let's take an equation. X square minus 2x minus 15 is equals to 0. Alright, the first step in solving any equation through factorization, you have to write it like this. You have to write two numbers over here. If you add those two numbers, so it should give you, add or subtract two numbers, so it should give you minus 2, and if you multiply these two numbers, so it should give you minus 15. So you have to look for those two numbers. What I think it should be minus 5 and plus 3. If you add minus 5 with the 3, so it will give you minus 2. And if you multiply minus 5 with the 3, so it will give you minus 15. So that's how we found the roots for this equation. Then just substitute it equals to 0. And find your required values for x. Now move on to the next method, that is called completing the square method. Alright, in completing the square method, first we will shift this plus 3 to the left side, to the right side. So our equation will become now x square minus 4x equals to minus 3. Now you have to concentrate over this thing, the coefficient of x. What you need to do, you just need to add minus 4x plus minus 4 upon 2. Whatever the coefficient of x is, you just have to divide it with the 2 and square it, and then add this to the left side and to the right side. Now simplify it a little bit. So we have this x square minus 4x plus 2 whole square is equals to minus 3 plus 4. Now this will become a formula of x minus 2 whole square. You just take this one and this one, write it in between, and you would decide your sign by this. If you have a plus sign over here, then write plus. If you have a minus sign, as in this case, so that's why I'm writing here minus only. So now minus 3 plus 4 will be plus 1. Now we have to further simplify it, as we know that when we have the square, so we take the root, square root on both sides. So x minus 2 whole square is equals to plus minus, because we are taking root on both sides, this square will cancel by the root. So we have over here x minus 2 is equals to plus minus 1, because root 1 is equals to 1. So x minus 2 is equals to plus 1 and x minus 2 is equals to minus 1. On simplification we get minus 2 will go to the right side, so x equals to 3, and this x is equals to 1 only. Now we have to learn how to solve a quadratic equation by using quadratic formula, because we have already learned solving a quadratic equation by factorization or the middle breaking or completing the square method. Now the third method is by using quadratic formula. First we have to write a formula over here, that is minus b plus minus root b square minus 4ac upon 2a. Let's take an equation and start solving by using this formula. Let's suppose we have equation 2x square minus 8x plus 6 is equals to 0. So a is equals to 2, b is equals to minus 8 and c is equals to 6. I will just substitute it into the equation. So minus 8 plus minus square root minus 8 whole square minus 4 2, the c is 6 upon 2a, it's 2 times 2, so x is equals to. Alright, in this way we'll be able to find the values of x by using the quadratic formula. A quadratic equation can give us different types of roots. Either they could be distinct real roots or no real roots or equal real roots. Let's see some graphical representation of different types of root and how we actually identify whether if it's real, equal or not real. The most important thing in this scenario is discriminant that come from the quadratic formula x equals to minus b plus minus root b square minus 4ac upon 2a. This b square minus 4ac, this is discriminant. This b square minus 4ac is called discriminant, and it decides if our equation will give us real roots or equal roots or no real roots. So let's draw some graphs of real roots, no real roots, and what are those conditions. Let's have a look. Alright, so first we are going to discuss about the real roots. If our discriminant has this value like b square minus 4ac, you substitute the value of a, b and c from the equation, and if you find your answer which is greater than 0, then it means that this equation will give you two distinct real roots, and definitely you would have two x-intercept that you could see here, that is alpha and the beta. There is a kind of difference between these two graphs, because in the first one, if you see over here, a is greater than 0. If a is greater than 0, then the equation will have the graph facing upward, or you could call it happy face. And if you have an equation in which the value of a is less than 0, it means minus 1, minus 2, minus 3 or so on. It doesn't matter, but if that thing is like less than 0, then this graph will be facing downward, and definitely it's a set face. This graph, the graph which is facing upward, it will give you minimum value, and this graph which is facing downward will definitely give you maximum values. Now move on to the next category of roots, which is equal real roots. Alright, so in this category we'll see what are equal real roots. If our discriminant, that is b square minus 4ac, is equals to 0, then we have equal real roots, and line or the x-axis is tangent to the curve. If you could just look at the figure, you'll find this shows like a is greater than 0, but if you just concentrate over here, this curve or the parabola is touching the x-axis and it's tangent over it. So this is the condition wherever you've been asked about equal real roots, and if they have given you any sort of condition in which you have to find the equal real roots, so you just have to put your discriminant equals to 0, and this is the most tested question you will find in the exam, and you will often come across with it. So now move on to the next category, in which we have no real roots. In this, we'll see b square minus 4ac is less than 0. So no real roots, no x-intercept, and y equals to ax square plus bx plus c is either always positive or always negative. Alright, so in this one, if you have your discriminant which is b square minus 4ac, and if it is less than 0, so you will have no real roots. As you could see here, this curve is not cutting x-axis, so it's not giving you any x values in it. In this scenario, this is a greater than 0 and this a is less than 0. So the equation ax square plus bx plus c is equals to 0. In this case, in both the cases, either it would be positive, always positive, or it will always be negative. So you need to keep that in mind. No real roots, no x-intercept. This is the condition for no real roots. Let's take some equation to further solidify our concept. How do we actually check it if some equation is giving us equal real roots or distinct real roots, or whatever type of root we are getting? Let's see. We have an equation x square plus 4x plus 4 Alright, in this equation we have a is equals to 1, b is equals to 4 and c is equals to 4. Let's apply the discriminant in it. B square minus 4ac. So 4 square minus 4 1 in the c. So 16 minus 16 is equals to 0. It means that this equation will give you equal real roots. Let's check another equation. We have a is equals to 1, b is equals to minus 2, c equals to minus 1. The formula for the discriminant is b square minus 4ac. So minus 2 square minus 4, 1, minus 1, 4 plus 4, and this is 8, which is greater than 0. So it means that this equation is going to give you two distinct real roots. In this reading, we will see how a line and the curve intersect with each other, and resultantly the roots that we are going to get after the intersection. We'll have a look over here. As you could see in the first figure, this curve is intersecting this line at 2 points. So it is going to give us two real roots over here. So we know the condition for an equation to giving a real root. Its discriminant should be greater than 0. So we should write here like it will provide us two distinct real roots. Now in the next figure, the curve is just meeting with this line, or this line is tangent or the curve. So we know that this is the condition for equal roots. So we are going to have the discriminant should be equals to 0. Two equal real roots. And line is tangent to the curve. Whenever you meet up with such condition, you have to keep that discriminant equals to 0. And you are supposed to think of like getting two equal real roots after it. Now in the third one, we have a curve is not even intersecting or not even meeting the line. So that's why we have discriminant less than 0. So this is the condition for no real roots, because there is no common point in between these two lines, the curve. Now let's solve some past paper question to further solidify the concept. Right, so in this question, determine the set of values of the constant k for which the line y equals to 4x plus k does not intersect the curve. Does not intersect the curve. It means that its discriminant should be less than 0. So let's start solving it. We have y equals to 4x plus k. We'll just substitute this value of y into the curve equation. So we get x square is equals to 4x plus k. Rearranging the equation, minus 4x minus k is equals to 0. we know the formula for the discriminant is b square minus 4ac, and we need to equate this thing should be less than 0 because there is no intersection in between the line and the curve. So from this equation, a is equals to 1, b is equals to minus 4, and c is equals to minus k. So minus 4 whole square minus 4 a, and c is minus k. So 16 plus 4k should be less than 0, and k is less than minus 4. The question is, find the value of constant c for which the line y equals to 2x plus c is a tangent to the curve. That is the most important thing for this question. By this condition, we know that we should need to equate this discriminant should be equals to 0. So now, just substituting the value of line into the curve equation, and we get after substituting the value of line into the curve, just simplify this equation, and this equation simplifies to 4x square plus 4c minus 4 into x plus c square is equals to 0. As we know that this line is tangent to the curve, so we need to apply the discriminant condition and put it equals to 0. So for this equation we have a is equals to 4, b is equals to 4c minus 4, and c is equals to c square. So substituting back to the discriminant equation, we have 4c minus 4 whole square. Write a formula here, b square minus 4ac is equals to 0. So b square minus 4, a is 4, and c is c square is equals to 0. Opening this identity and solving it, we get so 16c square minus 32c plus 16 minus 16c square is equals to 0. Then minus 32c is equals to minus 16, then c is equals to 1 upon 2. So this is the value of constant c. We need to substitute this value of c half in it so that we could get these two equations tangent on each other. Alright, in defining graphical quadratic inequality, we need to have a parabola. As you could see here, this part is y where the y is less than 0, and this part is where the y is greater than 0. If you are considering in your equation like you've been given with the less than 0, then you would write the range of x in this form: 1 is less than x and x is less than 3. But what if you've been given in the question if y is greater than 0? I would definitely give you some example after it. Once we are done with it, definitely we are going to solve some question, then you will see it. So if the y is greater than 0, then the part that is important for you is this part till here to here, and this part, because y is greater than 0 over here. As you could see your parabola, So this part is important for you and this part is important for you. So for y greater than 0 inequality, always you need to memorize this. You have to answer it like this: the part which is less than 1. So I would write here x is less than 1, and for this right part I would write x is greater than 3. That is very important concept and you need to memorize it. So let's take a question in which we could see what we actually do if in the question we've been given with the greater than or the less than. So how we are going to answer it. So let's say here x square minus 2x greater than 15. You have to simplify or find the range of values of x. So how would you do it? First, arrange the equation in a proper order. Minus 15 greater than 0. Then factorize it. I'm going to do it directly. I've already told you this method. So x plus 3 into x minus 5 greater than 0. Now we know that, and you need to write it for greater than. So definitely we are going to consider this case. For greater than case, I am going to write it. It would be x plus 3, so it will be x less than minus 3. And even if I try to plot it, so it would be somewhat like this: minus 3 and plus 5. Remember the sign change because we have plus 3, so I am going to write here minus 3. If I have minus 5 over here, so I am going to write here plus 5. Now the important thing is that the part is greater than, so definitely greater than part is this one. So I am going to write it like x less than minus 3 and x greater than 5. So these will be true values of mine. What if this question is given somewhat like this: x square minus 2x less than 15? So how are you going to do it? Again, same thing we are going to do here: x plus 3, x minus 5, and then less than 0. Now this is the less than case. So if x plus 3 into x minus 5 is less than 0, we know the method to write it is, it should be 1, it shouldn't be 1, it should be minus 3 less than x less than 5. So this is the past paper question in which find the set of values of k for which the line y equals to kx minus 4 intersect the curve. This is important: intersect the curve. It means that discriminant should be greater than 0 at two distinct points. That's important. So now what we need to do, we need to substitute the value of y into this, like the value of y from the line equation to the curve. So this will become kx minus 4 is equals to x square minus 2x. Upon simplification, this equation will become square minus x 2 plus k plus 4 is equals to 0. Now it's given in the question the line is intersecting the curve. So when it is intersecting, so I'm going to write here b square minus 4ac should be greater than 0. Upon substituting this in it, Further simplification, we get k equals to minus 6 and k is equals to 2. But the thing is that we are given with the inequality. So how are we going to solve it? This is the case of greater than 0. So for example, if we start drawing it, so it would be somewhat like minus 6 till 2, something like that. So minus 6, and over here we have 2. Important part is this part, because this is the region where y is greater than 0. So we have k plus 6 into k minus 2 greater than 0. So what I'm going to do here, x should be less than minus 6, talking about this part, and x is greater than 2, talking about this part. So that's how you actually answer for anything which is less than or the greater than. So this is all about graphical quadratic inequality. Good luck.